Thank you for listening in on my talk about process physics, time and consciousness, in which I try to explain how the process of nature can be internally meaningful and habit establishing. In this talk I hope to make plausible that the process of nature is routine based rather than governed by fixed and eternal physical laws. Counter to the currently prevailing view of a law-abiding natural world, process physics suggests that the universe in its earliest stage comes into actuality from an initially undifferentiated and structureless kind of pre-space, which by virtue of its universal interconnectedness entails a cyclic iterative update process. So in this way, nature forms a bioanalogous, self-organizing and internally meaningful whole in which all affects and makes a difference to all else. This in stark contrast to mainstream physics, which conceives of nature as if it were ultimately no more than a collection of law-governed, but by themselves inert and sterile, physical contents. Now, all this can be concluded on the basis of process physics, but although we all know about time and consciousness by first-hand experience, simply by waking up every day, this process physics is most likely still a complete unknown to most of us. So therefore, I'll try to give you a decent preliminary introduction by first discussing the history and current role of time in mainstream physics. So this is actually the same mainstream physics that has been criticized quite heavily by Lee Smolin in his recent book Time Reborn, in which he links the problems of interpreting what time is with the problem of what he calls doing physics in a box. After this, we'll automatically arrive at the consciousness part, since it is by authority of a conscious observer that mainstream physics has developed its method of doing physics in a box, which means cutting nature into smaller parts, natural systems, and then trying to capture them into nice and short mathematical equations. This second part has a strong emphasis on the mutual informativeness among neuronal groups contributing to the process of consciousness. This is largely inspired by Edelman's and Tononi's book, A Universe of Consciousness, but it's placed in the more process-oriented context of enactive theory and biosemiotics. Then we'll take a look at process physics, which can be seen as a neurobiologically inspired way of doing foundational physics. So we'll take a look at how it sets up a non-formal, self-organizing and internally meaningful process system based on mutually informative, noise-driven iterations. Through these noise-driven update iterations, habitually grooved but still constantly evolving activity patterns are being formed. So in process physics, the passage of time is an intrinsic aspect of the constantly self-renewing process system instead of a geometrized abstraction from the process of nature. Also, because process physics is based on mutual informativeness of its activity patterns, there's a strong link with the mind-brain's mutual informativeness as it is identified by Edelman and Tononi. So at the end of the presentation, I'll try to link together process physics with Edelman and Tononi's view on consciousness by looking at what they have in common, which is that they're both based on mutual information, or process informativeness as I like to call it. So the first moment that time was actually used in physics was when Galileo did his experiments on gravitation. One of his experiments was organized around an inclined plane like this one. By releasing brass balls at the top, he could keep track of the traveled distance by looking at the distance marks on the side of the ramp. Next to that, he arranged for a series of ringing bells that could be placed on strategic positions along the slope of the ramp. Like this, he could make the bells function as a metronome, more or less. with the bells ringing at an even rate, with equally long intervals between them. From this, he found that the traveled distance was proportional to time squared, as we can see in this table. But what he actually did was to compare the amount of change of one thing, the traveled distance of rolling balls, with the amount of change of something else, the number of bells that are made to ring. Now, by doing this, he basically translated the processness of nature into the length between ringing bells, thereby turning it into a geometrical timeline that could be used to make a graph like this, with time plotted out as a geometrical dimension. Now, it is also crucial for all following discoveries in classical and modern physics is the use of a time-based equation. The huge empirical success of these time-based equations almost makes us forget that a great amount of abstraction is involved, and also that lots of other equations, like this one, may be equally valid within the chosen scope of investigation. When ignoring these limitations, we can easily become convinced that our simple equations for our local isolated systems can be extrapolated to the entire universe. And that's in fact exactly what happened after Galileo. After Galileo, Newton was able to add force and mass into the mix, and in so doing developed the more advanced Newtonian equations of motion. Like this, the equations dealing with the gravitation of ordinary objects on Earth could be unified with Kepler's laws of planetary motion. Newton's work then led to the mechanistic clockwork universe worldview that motivated Laplace to claim that it should in principle be possible to calculate any future state for all of nature. So we could call this absolute determinism. So as an example of this way of doing physics, isolating a system, finding an equation, and then extrapolating it to a greater whole, such as the universe at large or into the future. As an example of this, we may zoom in on the Earth and the Moon, isolate them from their environment, and try to record their positions between fixed time intervals. In this way, we could get a sequence like this, with the Moon spiraling around the Earth, or better put, revolving around a common center of gravity. But nowhere in the planetary equations of motion can we identify a dedicated present moment. In fact, the physical equations in mainstream physics seem to lack any sense of a now and a preferred direction of time. In most cases, an equation can be read both ways, forwards and backwards, and if not, such as in classical thermodynamics, unidirectional time is already tacitly presupposed by way of the initial assumptions, but this just as a side remark. So the present moment can only be introduced by bringing into play an external present moment indicator, like this. And it can be seen to be present on an external abstract timeline, like this one. But with the arrival of Einstein's relativity theory, it became apparent that events could have a different order of occurrence for observers moving at different speeds. So the combination of Galileo's geometrization of time, the physical equations lacking a unique present moment and preferred direction, the loss of Newton's absolute time, and also the introduction of the Einsteinian Minkowskian four-dimensional space-time manifold, all this motivated mainstream physics to drop time altogether. It actually made physicists to argue that in reality there is no passage of time, but that all moments of all of eternity exist as a giant universal timescape, like this space-time picture of the Earth and the Moon, but then for the entire universe. In this way, however, all sense of processuality would be lost. Mainstream physics now claims that we live in a static, timeless universe, and that all experience of time passing by is illusory. But remarkably, mainstream physics, being itself an empirical science, is utterly based on experience to begin with. Enough reason for process thought to disagree with this timeless picture, simply for the following reason. It's not nature that's non-process, it's mainstream physics. So to find out how mainstream physics manages to lose track of nature's processuality, let's take a good look at how it is actually made to work. Firstly, a target system is singled out as some interesting aspect of nature, such as the Earth with its orbital motion. Such an aspect of nature can be expressed by using physical observables, such as mass, position, speed, etc., that can be specified in terms of numbers. Secondly, from the empirical data, a specific set of those numbers is chosen to serve as initial conditions, and then after an arbitrarily short interval, a second set is chosen as the immediate successor of these initial conditions, the physical result of some physical operation that is going on in nature. Thirdly then, the numbers for the initial and the final conditions are inferred to relate to one another by a mathematical operation that closely matches this physical operation. In this way, we suppose that the empirical data extracted from the so-called physical world is represented by the mathematical world, whose calculated results will have to be interpreted in order to confirm their agreement with the actually observed final set of empirical data. But we've already seen that this representation is an act of abstraction. This means that any resulting abstract equation should be converted back again into the empirical data. And it's actually those empirical data that make up the phenomenology of the process under investigation. So we must realize that the thus achieved empirical agreement is between phenomenal data and abstract algorithm, not between nature and mathematics. So crucially, the process of nature itself can only be approximated or implied by mathematical inference. Now, there always needs to be an encoding of raw measurement results into more polished data that can be mathematically compressed into a short physical equation. And in turn, there's also always interpretational decoding that predicts from the physical equation what the numerical values of future measurement outcomes should be. For sake of simplicity, we can then place the second time slices, or system states, the physical and mathematical results in the lower boxes, on top of the one with the initial conditions to end up with what is also known as Robert Rosen's modeling relation. And what is now particularly interesting is that both the measurement encoding and the predictive decoding cannot be derived from the data or the algorithm itself. So, analogously to the external present moment indicator, encoding and decoding are in fact external manipulations. Although they give shape to the hard and exact physical equations, they rely on subjective choice. And also we can see the appearance of a timeline resulting from another subjective choice, namely the decision to abstract from the process of nature in terms of phenomenology-based consecutive states. In other words, The relation between the natural system's empirical data and its formal algorithm is highly subjective. This is often played down by arguing that data and algorithm refer to the process in itself, that they represent the observed process in question. But this is actually not the case. In my view, it's way better to look at physics itself as a semiotic process. Like in quantum physics, it has a preparation part, in which a potential target system is singled out or soaked loose from its environment. It also has an observation part, in which the singled out target system is evaluated by its effect or impact on a conscious observer participating in the semiotic process. And finally, it also has a formalization part, in which the conscious observer formulates a modeling relation between data and algorithm that are meant to refer to the target system. All this occurs within an embedding context of use and depends on the entire foregoing evolutionary history. So even in physics, the entire context of use and foregoing history of the observation process make a difference to the end result, just as in natural evolution. For instance, when we look at the evolution of the eye, it evolves under pressure of the organism's inner and outer environment. It turns out that the evolutionary trajectory depends very much on perception, action, manipulation loops. For instance, first a photon will hit a light-sensitive nerve cell in the skin or in the retina. Second, all kinds of action repertoires are being activated, the most straightforward of which is probably a sensory motor repertoire, which stimulates muscle groups. This in turn may manipulate the living environment of the organism in a way that affects its survival. In fact, it is the bundling of many such perception action manipulation loops that will enable the formation of an Uexküllin Umwelt, or a biosemiotic living environment, and the formation of a sense of self as two aspects of the same process. In this way, the organism learns how to make sense of nature by living through all the changes in its physiology and body states that are the result of the organism's interaction with its environment. This is basically the essence of perceptual categorization. Perceptual categorization is the process of carving up nature into categories, although nature itself does not contain any such categories at all. Through perceptual categorization, we gradually get to differentiate conspicuous foreground patterns from less relevant background patterns. To begin with, incoming visual stimuli are channeled via the relay center of the midbrain to the visual cortex for processing, and then back again. After this, the visually processed signals are sent to the prefrontal cortex, which plays a role in linking sensory motor activity patterns with internal goals of the organism. This can occur, amongst others, because dopamine-releasing reward systems in the brainstem region project specifically to the prefrontal cortex. Then, also the premotor and motor cortex get involved, so that they can set the musculoskeletal apparatus in motion. Like this, world-related sensory motor and other exteroceptive signals can acquire somatic meaning through their linkage with organism-related interoceptive and value-related signals. For instance, when auditory neural signals prompted by a ringing food bell become coupled with nervous signals relating to the secretion of saliva, as in classical conditioning experiments. Hence, as ongoing perceptual categorization makes a difference to the mind-brain's association patterns, as well as to the organism's overall physiology, it enables the conscious organism to recognize different outer organism world state by living through the therewith associated inner organism body states. From an information theoretical perspective, the emergence of each such conscious categorization, or percept, is an act of uncertainty reduction. That is, given the huge combinatorial potential of intro and extroceptive signals, each conscious categorization rules out a vast multitude of other categorizations that are potentially available to the organism. In fact, each conscious categorization makes a unique difference to all the mind-brain's other activity patterns, which, in turn, will give rise to other such conscious categorizations and even more composite concepts ensuing therefrom. Together, all these activity patterns participating in perceptual categorization and the binding together of extroceptive signals, interoceptive signals, value signals, etc., all these signal patterns, all these activity patterns, maneuver all through the brain as one ongoing flow process which constantly changes its local density depending on shifts in attention, and which sensory motor and somatosensory circuits are involved. In early life, all these signals participating in this flow process are still relatively undirected, but the release of dopamine and other neuromodulators more or less streamlines neural pathways that are active at that moment, for instance the motor circuits for grabbing and the visual circuits for optical focusing. In this way, we can develop habitually grooved action repertoires, especially in newborn babies. In the formation of such habitually grooved perception action repertoires, activity patterns with similar orders of magnitude are more likely to connect with each other. Through repeated activation of action potentials, relatively strong and much used connections will hook up and become more permanent, thus ending up as the major pathways. Although they're a minority, they will persist by being used. However, changing external contexts constantly trigger the development of adaptive behavior as old action repertoires become ineffective, so that new pathways can grow as initially undirected neural circuitry becomes conditioned and strengthened. As a process in action, it would look something like this. Certain aspects of the resulting perception-action manipulation loops that are associated with our conscious stream of experience can even be visualized in a brain scanner. During dreamless sleep, when a person is not conscious, stimulation by an electromagnetic coil above the head only leads to local activity in the cortex that will almost directly stop when the stimulating pulse is removed. During wakefulness, however, activity patterns go all over the cortex and persist even when the stimulating pulse is switched off. This looks like this, with activity patterns moving all over the thalamic cortical region. Neuronal groups that are continuously affecting and actively giving form to, or in other words, informing each other's firing patterns, stop talking to each other during dreamless sleep. So it is the mind-brain's massive culmination of mutually informative activity patterns that is associated with the appearance of consciousness. And these mutually informative activity patterns are precisely the essence of process physics as well. Process physics is a neurobiologically inspired way of doing physics that starts out with a noisy substrate to model the initially practically uniform and structureless universe. So noise is used in process physics to model nature's initial absence of order. In process physics, it is assumed that the universe started out as an initially uniform, basically orderless realm, or in other words, a noisy process plenum. And because we, as later arriving observers, are in fact seamlessly embedded participants of this same process plenum that we are observing, we can also quite commonsensically diagnose it as being self-referential. Now, process physics uses these two characteristics, noise and self-reference, to realize a pre-geometric startup modeling of the universe, which is based on self-referential noise. This can be imagined like this buzzing, noisy picture here, although it must be emphasized, of course, that this is just an analogy and not the model itself, let alone nature itself. Each self-referential loop basically works to add the influence of the system's past activity together with additional noise, so that the already present activity pattern can be renewed. So basically it has the effect of an update iteration. This is very similar to the process of neuromodulation in the almost unconditioned brain of a newborn baby. It follows the same basic principles. Although in the case of the process physics model, there seems to be no starting structure like a pre-wired brain, just a uniform, noisy substrate. So there's no pre-developed starting structure, but just random noisy activity patterns. Remarkably though, when there are enough iterations, more stable and relatively isolated branching structures start to emerge from the noisy background activity. These are emergent neuromorphic or neural network-like structures with an internal connectivity that approximates the geometry of a three-dimensional sphere. To be more precise, these emergent process structures branch out so that they have a natural embedding within a three-dimensional hypersphere S3, which is a technical term from geometry. So in this way, they can basically be seen as bits of emergent geometry. They can be imagined to arise as dissipative structures like this. And they can be seen to emerge from the uniform background like this reaction diffusion model. In this reaction diffusion model, relatively autonomous and persistent reaction diffusion cells emerge from an initially uniform and patternless background medium. Similarly, in process physics, the startup cells arise from an initially homogeneous and orderless noisy background. We may also look at it as primordial and as yet unactualized potential. With more and more update iterations, even higher order structures can develop, arguably with all properties that we can also find in the observable phenomena of our own natural universe. Like this, we can see the emergence of quantum behavior, a quasi-classical world with gravitational and relativistic effects, non-locality, and also a present moment effect inherent to the system itself. And last but not least, it also exhibits the built-in potential to develop into a giant neuromorphic structure. This entirely in line with the outcomes of the Millennium Simulation, as performed by the Virgo Consortium, which is a partnership which includes astrophysicists from the Max Planck Institute. In our current standard model of cosmology, which forms the basis of the Millennium Simulation, the dark matter hypothesis is needed to account for the difference between the measured gravitational effects of large astronomical objects, such as galaxies, and their calculated mass, which is computed on the basis of the observable matter of stars, gas clouds, etc. within these galaxies. So the Millennium Simulation uses this hypothesis to get our known physical laws in tune with gravitational measurements and to thus arrive at the neural network-like branching structures that represent the universe at a supragalactic level. So here we can see some intermediate stages in the evolution of the universe. From the cosmic microwave background at the left, to a moderately uniform distribution of cosmic structures, to eventually a neural network-like distribution at the extreme right. But the presence of dark matter is merely postulated, and thus far it has never been detected. It can even be questioned if it ever will, because it seems more likely that dark matter is just a theoretical artifact to be able to correct the deviations occurring between calculations and observations. However, when performing any premature extrapolation of physical equations to make them apply to the universe as a whole, it is to be expected that deviations will occur. After all, as Lee Smolin has argued already, initial assumptions that work quite well on a relatively local scale need not be applicable on the level of the universe at large. So the Millennium Simulation requires the dark matter hypothesis to get the neural network-like cosmic structures that we are navigating in this video clip right here. In process physics, however, this neuromorphic behavior emerges spontaneously, without the need for such speculative hypotheses like dark matter. So to wrap it all up, the brain facilitates the coming together of multiple somatosensory, sensory-motor, interoceptive and exteroceptive activity patterns so that a bound-in-one integrated experience can occur. And although we may indeed be able to distinguish several different aspects of a certain phenomenon, like color, shape and texture, all of which with their own possible neural correlates, phenomenal experience will always be integrated. This means that it's impossible to experience these individual aspects separately from all the others. This integrative binding of perceptual modalities is achieved through the mutual informativeness between neuronal groups within the thalamocortical region. And as we have seen in the consciousness part of the presentation, when mutual informativeness is absent, conscious experience will not occur. So here we have an unconscious person in deep sleep, or perhaps in a coma. There's definitely signal traffic between neuronal groups, but it's not reciprocating. There's no mutual informativeness. In a minimally conscious person then, we can already see more mutual informativeness but it occurs within limited regions or islands within the thalamocortical system. And finally, in a normal awake person, we can see the entire thalamocortical region engaged in mutually informative activity patterns, which should be the case in all healthy conscious individuals. As explained earlier in the process physics part, mutual informativeness also plays a crucial role in process physics, where all emergent structure can be imagined as mutually sensitive spherical cells. In turn, these cells are themselves also blooming and buzzing with activity patterns, whose relations are made up of even more such processual cells, thus making up a giant neural network-like process system with fractal structure formation. So, all in all, we as conscious beings are not external observers, but rather seamlessly embedded within the world we are trying to make sense of. Moreover, we're equipped with a mutually informative, habit-establishing mind-brain, via which we can meaningfully relate to the universe as a whole. In turn, this universe is itself mutually informative and habit-establishing at the level of supragalactic clusters, as well as on the most primitive level of structure formation, which is the noisy starting level of process physics. All this can only lead to one conclusion, that all is mutually informative and that nature is internally meaningful and habit-establishing from the smallest of beginnings to the greatest of extents. Thanks very much for your attention. If you have any questions, then drop me an email at the email mentioned below, and hopefully I can give you a useful answer. Thanks very much. Bye bye.